Hey, good afternoon, everyone. Good
Good
afternoon.
afternoon, Professor. I
Good. How
had
are
a
you?
I had a question. I'm good. How are you?
Good. Yeah, Shanaz. Is that Shanaz?
Yes, Professor, that's Shanaz.
Yeah, yeah. Go ahead.
I had a question because I was looking through the syllabus. I'm a little
Mm-hmm.
lost and I apologize for that, but I saw it said Connect. Do we have like
No,
an online bookstores that we're doing any
Good
assignments
evening,
from?
Professor.
no. Good evening. I don't know who was speaking, but let me answer Shanaz. Okay, first. That
Thank you.
is during the regular semester. That's because we during summer we don't have time. We don't have time for Connect. So here in the announcements, and everything that's posted on the announcements are also emailed out to you. So you must have received that email at some point. And here, see, I use BMC's custom edition, which is cheaper than ebook or regular edition or finance application, Cornet fifth edition. However, we don't use Connect during the
Okay.
summer due
All
to the
right.
short span, right? So
Yeah.
the syllabus, yeah. So we don't use that. But if you want to use it separately on your own, uh, that, um, obviously, if you the price of the book would have been much more expensive
Uh,
because
no, Professor. I think I'm good on trying the Connect book. I was just worried that maybe we had something due on Connect and I wasn't doing it. So yeah, that's
no,
all.
no,
Yeah.
no. I mean, I implemented and I enforced that policy during the regular semester, but
Gotcha.
during the summer we have only 5 weeks, and there's no time you can do all of that
That's
during
very
this.
considerate of you, Professor.
Right,
Thank you.
right. So maybe the I believe summer syllabus is a little different than the regular semester syllabus. Let's go to summer syllabus. Yeah, summer syllabus, and item. Okay. I still left it as ebook. You can, as explained, and I don't have anything. I don't have anything about Connect on the syllabus during the summer. Okay. Um, and also, I used to use BMCC Custom Edition, which was also authored by me. However, the ebook is much cheaper nowadays because you can have like $50. Uh, you can pay just $50 for uh, one semester subscription. So most students, prefer to use the ebook. So I basically got rid of the custom edition, which is a print edition, and so it's no longer in print. And because during the summer we don't use Connect, so there's no. That's why I mentioned. I believe I said here, just buy any used book because uh, it doesn't matter. Yeah, there are plenty of bargains for physical fourth editions, right? Um, and since used books don't come with the Connect, because think about it, used books, somebody has already used it. Somebody already used the Connect access. And think about it, Connect access is, it's like an online key. It's like an account. It's an account, and if someone has used that access code to create an account, it cannot be used by anybody else. afterwards. And it has expiration, right? Obviously, if someone uses that access for 1 semester, and then after that it expires, and it is um, associated with that particular individual only, right? So ebook, the used books cannot come with any access code because there's no access code anymore, right? And for our purpose, any used book is okay because we don't use Connect during the summer, right? Alrighty, so I believe that cleared the question, and let me also make myself a moderator. Okay, so we are, let's see. So today, we have just a couple of more videos left in well, let's go to the course material. We have just a couple of more. Yeah. APY, time value of money, APY, annual percentage rate, and rule of 72. And if we have some time, we're going to also review future value of multiple annuities. Okay, so let's take a listen. Okay.
So today's topic is effective interest rate, or APY. So, what is effective interest rate, or APY? Now, APY stands for annual percentage yield, and that term is as opposed to APR, annual percentage rate. So how are these two rates different? And how is APY different from APR? Now, and since APY is effective interest rate, in other words, APY means effective interest rate, so how is effective interest rate different from just interest rate? I mean, think about it. Just because the name is different, it should mean something different, right? And effective, I mean, the term effective means that's what really effectively applies, right? So that means that's the rate that effectively applies, right? And also, if you think about the difference between, just by semantics, right? If you think about the difference between APY and APR, now think about it. Yield, that's annual percentage yield. Now, do you remember from the first topic we talked about, right? The return on investment, the first topic, the very first topic. Towards the end of that topic, we talked a lot about yield, right? We also talked, why? Because we talked about the yield curve. And at the time, I told you yield is just another name for annualized return, annualized, okay? And we also, prior to that, we talked a lot about the difference between the holding period return and annualized return, right? Remember house value example, scenario 1, scenario 2, right? In scenario 1, what was the scenario 1? Scenario one is the case where you buy the house and use it as your home, simply as a residence, right? Whereas in scenario 2, you purchase the property for investment purpose or rental purpose. So the difference between scenario 1 and scenario 2 is that in scenario 1, over time there will be only capital gains or capital loss, right? Because the house value, the property value would go up or go down. And that's the only source of cash flow, right? Either capital gain or capital loss. But in scenario 2, there are two sources of cash flow: capital gains and rental income. Capital gain, capital loss, and rental income. And I told you the holding period will be different, right, for capital scenario 1 and scenario 2 because the cash flow during the holding period would be different, right? Of course, the cash flow during the holding period in scenario 2 is greater than scenario 1 because there is additional cash flow of rental income, right? And I also told you that the both scenario 1 and scenario 2 are exactly an analogy, the same analogies for zero coupon bond and coupon bond, right? Because in scenario 1, in the sense that the zero coupon bond doesn't pay any interest, right? And in the sense that it is sold at discount, it is exactly like scenario 1 because there will be only capital gains. And coupon bonds are like scenario 2 because there will be capital gains or capital loss, which is like at the end, at maturity, you redeem the face value, right? And then in the meantime, during the holding period, you receive the interest or coupon interest on the bond. Well, and then depending on the holding period, right? If the holding period is 10 years, let's say you were holding that house for 10 years, right? The total return would be the source of the holding period return, right? In other words, total return and the holding period return would mean the same thing. But then the reason for, and I told you we need some metrics or some way to compare the assets being held for different holding periods, right? I mean, you cannot directly compare the holding period, the total return on 5-year holding period directly with the total return over 10 holding period because the holding periods are different. I mean, the longer the holding period, the chances are that the total return would be greater than the shorter return on the shorter holding period, right? So it cannot be a fair comparison, right? So that's brought us to the geometric average. Remember that? Because annualized return, I mean, think about it, to compare these two different returns on these two different holding periods, right, of two separate assets. You would have to, the best way to do that, by just, any common sense would be the average, right? To take the annual average of those returns, right? And then that brought us to the question of whether it is okay to take simple average or arithmetic average, which is the basically the average that you generally know of, right? And until that point, you didn't know the difference between weighted average and simple average, and you didn't know the difference between arithmetic average and geometric average, right? And at that point, I told you that because of the compounding going on, right, over the during the holding period of that particular asset, you can use simple average. You have to use the geometric average, right? And that was the first time you met the geometric average, right? And later in the, as we were discussing the time value of money, right? Then we talked about the difference between, as we were talking about the compounding formula in single cash flow model, right? You were able to be introduced to the steps of derivation of the geometric average, right? Remember that? Because only then you were mathematically prepped, right, to be introduced to the steps of derivation for R, the rate, which is the which was known to you as geometric average until that point, right? So then our next question is, the APR is the rate or the quoted rate, right, the interest rate, the quoted interest rate. In other words, that's the nominal interest rate. They quote you when you, let's say you go to the bank, you deposit your $10,000, right? And you ask them, so what is the interest rate? Oh, it's 6%. They say that is APR, that is the quoted nominal interest rate. But now let's think about it. Depending on when you put your money into the bank, depending on the product, right? Depending on the product. For example, of course, you wouldn't put your money into just a savings account. And you know that very well. You know why? Very well, because in today's macroeconomic environment, savings account doesn't pay any interest, right? It's almost 0.1%, and I don't think it's even 0.1% even these days, since the last time Federal Reserve slashed the interest rate to zero. I mean, that means Fed funds rate.
Well, again, you need to take it with some grain of salt, as I always say, because this, as I already clearly clarified, that this video was made in 2020, and as of that time, right, the benchmark interest rate was like 0.25, right? Fed funds rate was between 0 and 0.25. And since then, since 2022, then interest rate went up. Now it's a Fed funds rate is somewhere between 5.25 and 5.5. So take it with some grain of salt. Okay.
That was just about a week or two ago, right? So now you can't even. I don't think you can even get 0.1% on the savings. So nobody put if you are sensible and you don't need this $10,000 anytime soon, then you would put it into a CD, right? But again, CDs used to pay something like 2%. Even last year, 2.5%, or at least even early this year, 1.75%, or and after March, the second week of March, when Fed chairman, due to this pandemic crisis, in an effort to boost the economy, the Federal Reserve slashed the interest Fed funds rate back to zero. So therefore, all the interest rates are basically tied together with the Fed funds rate, right? In the for short-term interest rates, right? And for long-term interest rates, we did this in quiz 1. Long-term interest rates are based on 10-year Treasury note yield, right? So now here comes the term yield again, and in topic 1, right? In ROI, we talked about yield curve. At the time, I told you yield is the annualized return, right? So then you might say, now you can connect this now with the we did geometric, that's the annualized return. Yes. So yield is another name for annualized return, annualized. But then, isn't APR anyway? If that's the interest rate that I would earn my CD, wouldn't that be also? Wouldn't that mean annualized return? Yes and no. Why? First of all, APR is equal to APY if the compounding frequency is annual. Okay, you understand? If compounding frequency is just once a year, then there's no difference between APR and APY. Okay, but then that means there will be difference, right? There will be difference if the compounding frequency is not. If the compounding frequency is greater than 1, then there will be a difference between APR and APY. So let's think about it. Let me stop this and take you to. Let me take you to the $10,000. Oh, it says 1,000, but let's make it 10,000, just like our example. Okay. Okay, let's all make it 10,000 through and through. And I've been telling you I've been preaching about the importance of good keeping. So make it neat. I would, yeah. You see what I did? I just simply, I think that's not the crucial. Of course, it's not a crucial issue, but I would like to keep the model, neat, right? The neat structure, neat organized structure is also very important, right? Then, obviously, anybody who looks at the model all in a uniform structure and uniform format would find it more pleasing than, or in a more less stressful to look at something that is well and neatly organized than something that is just chaotic or undulating, or right something less well taken care of, right? So anyway, our point is that this is our example. Let's give it 2 decimal places. By default, at least 2 decimal places, 2 to 3 decimal places. Now, so if you put your $10,000 in CD, right, and the prevailing market rate is 6%, and you put it for 5 years. But why do I have so many rows? Because I have different scenarios. Now, of course, you can tell in this means compounding is just once a year, twice a year, so semi-annual. That's only compounding, monthly, weekly, daily, and this is continuous compounding, right? Why? Because that means infinity, right? If the compounding frequency is infinite, then that would make it, continuous, right? The continuous time. So let's see the difference. We know, we already know that the future values will be different depending on the compounding frequency, and you know by now already that the more frequently compounded, or the higher the compounding frequency, the greater the future value. Okay, so that's nothing new. That's something we already know. So the usual thing, the periodic rate, APR divided by M, and since in this case in annual compounding, since the M is 1, it's not gonna make any difference. It's still gonna be 6%, right? The total number of compounding, because it's annual, is going to be 5, right? So the future value will still be T times 1 plus R raised to N, right? There you go. But now, let's do the rest of it. I'm going to highlight. I'm going to select 3 cells altogether and drag it down, okay? And we'll get, as expected, we'll get different results, different future values, right? And these different future values are clearly the proof of what I said. The greater the compounding frequency, the greater the future value, right? Now, and then one question arises then. I don't know if that question also arises in your mind or not, but at least it's plausible to, and it's quite, natural that some people might come up with a question such as, so let's take a look at this quarterly compounding, and quarterly compounding is clearly better than annual compounding. So then your question is, if there is one single annual interest rate, right, that would give us the same future value, right, without quarterly compounding, right? If, in other words, if I do just annual compounding, right? Just annual compounding, compounded just once a year. So over 5 years, there will be only 5 compoundings, right? Now, I did this because only because the compounding was quarterly, right? And so this quarterly rate was compounded 20 times over 5 years, right? And this is the result of the quarterly compounding for 5 years, right? But if it wasn't quarterly compounding, but just annual compounding, right? So what kind of annual rate will give me the same future value, right, as the result of quarterly compounding, right? So what if there is an annual APR that would give me the same future value as quarterly compounding? What simple annual rate will give me the same future value? Understand? Okay. In other words, if the compounding was not quarterly but rather annual, right? With annual compounding, 6% compounded annually for 5 years won't take us to this future value. It will only take us to this future value. So obviously, we'll have something greater than this, isn't it right? It will have to be something greater than 6%. So the question is, what kind of APR would take us to the same future value as this, right? That is the question. Now, so that's also called APY, okay? And then the formula for APY is not a very difficult one, okay? So let me get back to the PowerPoint and show you, or let me get to the whiteboard, okay? Let me stop this. So here on the whiteboard, I will put So effective interest rate, okay, I'll call that R star. And R star, which is also APY, right? It's nothing but 1 plus APR adjusted for divided by M raised to M, right? Now, isn't it something already very familiar? Isn't that right? Because it's basically what is this? This is basically the periodic rate, right? We've been using the periodic rates all along, right? Because that's what really matters in compounding, right? And this is what? That's the compounding frequency. So in other words, this is basically what within a year, right? During within a given year, how much compounding is actually done, right? And the result of that. So if you have $10,000, and then just putting it just for 1 year, this will give you actually the future value at the end of year 1 if you do this, right? But then think about it. We are talking about the rate. I mean, this is basically interest rate, but 1 means there's no present value or principal multiplied to this, so this is only the rate portion, right? But this is gross return, gross rate of return, meaning because 1 is the original principal itself, right? So just to get the net return, you will have to net out. You'll have to net out 1 or subtract 1, right? Okay, and this will give you only the net return or net effective rate or APY. Okay, so that's not a very difficult thing. APY, this is for discrete time compounding, right? What about the continuous compounding? We should talk about the case of continuous compounding. First of all, you remember in continuous compounding we have to use Euler's number, right? But again, then we didn't get a chance about how to use Euler's number in compounding. So suppose we are trying to find the future value using continuous compounding. So how do we do that? Of course, P, future value is P times principal times, right? And you might think, 1 plus something. In continuous compounding, yes, that we can do it like that, but the result would be anyway something like this. The result would be we'll have to use Euler's number. So we multiply by Euler's number, right? Raised to APR times T or N, right? I mean, that's times, right? Times APR times T, okay? Because this is already, 1 plus, right? 1 over infinity, right? So then in this case, right, if you want to find the effective rate in this case, all you need to do is simply E raised to R. This R means, APR. You don't need T because we are just, 1 year is enough, right? Minus 1, okay? E raised to R minus 1. Now, when doing this, entering this in Excel, right, you'll have to know in Excel, Euler's number is called exponential function, exponential E, right? So there is a already a pre-built or pre-built function for that, which is called exp. Okay, exp. And then in the parentheses, you enter the APR or R times T. Okay. You might wonder, don't we need to raise it to E? This is, this is not multiplying. This is not multiplication. It's, it's automatically, when you enter exp, whatever comes inside the parentheses is, automatically recognized by Excel as exponent. Okay, so you don't have to worry about it. All right, so so let's switch back to Excel. So here, what do we do about the future value? All you need to do is P times exp, exponential function, right? Let's see already. You can just No, 6% times T. It's slightly better than daily compounding, right? Now, APY, or effective interest rate, is, oops. So what do? 1 plus APR over N, right, in the parentheses, and then raised to N, right? Now here, but then think about it. This is already that, isn't it, right? This is already, the periodic rate is already 1 plus APR over N, right? So all you need to do is just recycle that result and raise it to N, right? You see what I'm talking about? Because the periodic rate is, I'm sorry, what I'm saying is, open parenthesis, I just, you do this, in other words. If you do this, then -1, right? If you do this, then this E2 is already, APR over N, right? So we are exactly, doing that, 1 plus APR over N raised to N -1. So hit N. Of course, in case of, in case of annual compounding, I've already told you this. I've said this, several times already, over and over. There's no difference between APR and APY. But then try this, right? They are clearly different, right? Isn't it right? And then what about the APY for the continuous compounding? All you need to do is EXP, right? And just and then hold your mouse, or keep your hands firm on your laptop or computer, because a slide of a hand could result in a disaster. Now, then right, exponential function, right, raised to R -1. Hit enter. You see why continuous compounding is still better than, right, anything else, still, right? Now, so this is how you find the this is how you do the continuous compounding, and this is how you find the APY. Now let's go back to the slide one time, and then take a look at the title: effective interest rate. What does equivalent annual rate? That simply means that is equivalent. That gives you an equivalent result of continuous. That would give you an equivalent result to a higher compounding.
Okay, so it looks like this part, right? In this segment, somehow the material wasn't shared. So let me skip this and
frequency. Then just AER, annual rate, annual. The actual errors, effective. End of recording.
Okay. Anyway, so we're gonna do the Excel exercise of APY. So I want you to all open this file. I mean, this is the same file. You worked on single cash flow model. You worked on multiple cash flow model, right? So if you have downloaded it, retrieve it from your own computer, or if you haven't saved anything, I mean, if you have saved it on your computer, you have it. If you haven't, you need to download it from, of course, you need to download it from our right, topic 3 folder, right, this file. So if you have it in front of you, then you need to click on the bottom tab that says EAR or APY. Click on the bottom tab, right? Click on that bottom tab, you will see, right? Actually, let me get rid of. Let's get rid of these, right? Let's get rid of. It's already done, so I want you to clear everything. the highlighted, right? Clear everything in the highlighted area. Come on. My mouse has gone to, I mean, my keyboard has gone to sleep. I don't know. If you can, please. Because it's Bluetooth keyboard, it goes into sleep every once in a while. Oh yeah. It's gone. It's taken out. However, why only one? That's weird. Oh, yeah. Okay, I'll just then not delete but clear. Okay, so clear this highlighted area. So you have, so this is an exercise of exercise to find APY, right? So what's the formula for APY? Formula for APY is 1 plus APR over M, right? Raised to M. Well, we know APR over M is R, right? It's already, we already know. So what if, and then let's see what the APYs are when the compounding frequency is annual, semi-annual, quarterly, monthly, weekly, daily. I mean, if the compounding is 1,000 times a year, 10,000, 100,000, 1 million times, right? 10 million times, 100 million times. And practically you don't see any difference beyond, beyond 10,000, right? 10,000 compounding frequency per year. Of course, this means infinity, right? Infinite compounding per year, right? So that's, continuous compounding, right? So future value, simply, right? We all know present value times. So everyone is doing this with me? Everyone? Is everyone with me?
Yes, I'm here, Professor.
Okay, all right. Thank you. Thank you, Rostam. And yeah, Zainab. Okay, thank you. What about the other people? Other than these three people, everyone else is very quiet. Um, anyway, I will have to assume everyone is following me and doing this, right? Everyone is doing this also at the same time. Okay, 1 plus APR divided by M raised to, oops, T times N. Okay, of course, you won't get anything, I mean, this is basically, this is basically annual compounding, which is very, very basic single cash flow model. And compounding frequency is 1. So whether you make these as adjustments or not, it doesn't matter because 1 doesn't change anything. However, it's for uniform structural uniformity, I've been telling you, because by doing it this way, you can just apply it to the rest of the table, right? Now, let's find APY. APY is, again, then 1 plus APR over M raised to M, right? This is the formula for APY. There you go. Minus 1, I'm sorry. Minus 1. You see, without subtracting 1, it will be 106%. Of course, then that's gross return. But return is always net return. We express return as net figure, not as gross number, right? Now, what is this? See, instead of APR, I put 1 there. What does that mean? 100%. APR is 100%. That means, double growth, right? If the growth, which is, of course, only experimental. I mean, because nobody, what kind of bank gives you 100% interest rate? No. So it's just experimentation, right? So this is, 1 plus 1 over 1 raised to M. Okay. I need to subtract 1 here as well, but I'm leaving it. I'm leaving it as gross return. I mean, if you want to see net return, you must subtract 1. But to see gross return, right? Gross return 200%, right? Now let's see. Highlight all these 3 cells. Let's drag it down all the way to, right, this point, right? Because for continuous compounding, we use different, we need to use, Euler's number, right? Because think about it. Euler's number is when this n goes to infinity, right? Right? N goes to infinity. So we need to use Euler's number for that purpose, right? Now you might wonder, what is the difference? I mean, you don't see much difference after this 10,000 compoundings per year. However, it's only because you see only up to 3 decimal places. If you increase the decimal places, let's increase the decimals, right? You see the difference, right? You will see the difference, right? Clearly, right? Again, APY or effective interest rate is basically what kind of simple interest rate or what kind of just simple interest rate, right? What kind of annual interest rate, what kind of annual APR will it take to take your $10,000, to grow your $10,000 to this future value, right? When compounded just once a year, only by annual compounding. It will take, now in this case, 6% APR grows your $10,000 to this future value, 13,000 something, 498, in 5 years, because the compounding is like, there are 100,000 compoundings a year. However, if this rate, APR, is just this, then it will take just annual compounding, not 100,000 compoundings a year, annual compounding, just one single annual compounding, right, for 5 years to take you to the same future. Now, trying to find So now, what is then, what's going to be the future value under continuous compounding? Well, it's present value or principal times EXP. Euler's number in Excel is EXP. And then U in raised to T times R. I mean R times T. So this is already raised to, right? And what comes in the parenthesis is already exponent. Okay. So 6 times 5 years. Enter. Right? You might say, what? It doesn't look that much different. Of course, it doesn't. It's only a matter of how many more places you use. And you might say, oh, this is 100 million, right? Oh, well, then why is it decreasing? I mean, no, it's just it's just the limitations of Excel. I mean, beyond Excel doesn't make any difference between. I mean, Excel is set to, infinity in Excel. It's just the technical issue. Infinity in Excel, there's a limitations to what it can do. You cannot, because infinity is a very theoretical concept. So Excel is just set to cut off somewhere, right? It's designed to cut off at some point, expressing when it's calculating infinity. Anyway, so it looks like these are better than this, but not necessarily so. The reality is not like that. Anyway, APY in case of exponential function is EXP raised to R minus 1 and then if you do it, if you assume double growth, right? And this is the concept that we emphasized a lot during the lecture on Euler's number and natural log. So it's just EXP raised to one itself. 1 is 100%, right? R, right? The rate. And see, this is that beloved E, right? 2.7182828, etc., right? So this way we can confirm that the APYs are clearly, the reason that the future value is higher when compounding frequency gets higher is because you have higher effective interest rate, right? Effective rate or APY, right? They go by many different names, right? Okay, here. I believe. So EAR, that's effective annual rate. Effective annual rate, or sometimes equivalent annual rate. Equivalent annual rate. Sometimes they call it AER, annual equivalent rate. But they all mean the same thing, effective interest rate or APY, right? Annual percentage yield. Mathematically, and for simple, as a commonly used mathematical symbol is R star, R star, right? R star. All right. So everyone got the same result. I hope everyone got the same result. Right? Everyone got the same result.
Yeah.
Please. All right. Very good. Very good. Very good. Only 2 people answered. I don't know. Other people did. But something like this, you need to verify, right? Something like this, you need to check out yourself and confirm that you get the same result. Now, then our next video is rule of 72. Let's take a listen. This is not really, not that difficult concept. It's just some kind of shortcut method. And in accounting, they like this, sort of, shortcut, shortcut for dummy type of thing, right? And, there are many books that are titled "Something for Dummies," something for dummies. But anyway, let's take a listen.
Hello. This could be for both, time value of money, or well, as far as it is about time value of money, it can apply to any class. But today's topic is optional. Okay, it's an optional topic. Why? Because it's about rule of 72. And I normally don't talk about rule of 72, but the only reason I'm talking about it is because in accounting, generally, or some sort of self-guided how-to books like something for dummy, right? They always mention rule of 72 as if it is some magical a formula or magical method. But I'm trying to demystify that mysticism about the rule of 72, or whatever they make so much emphasis in accounting or in books like something for dummies, right? Well, basically the rule of 72 is simple. It's really watered down method to find out how long it's going to take to double your money, double your investment. So for this example, let's take a look. You have $10,000, right? And then provided that you have certain interest rate, and the interest rate is not found here, but it will be given, right? Given certain interest rate, how long is it going to take to double your money? See, doubling, if you put $10,000 into a bank or into an investment instrument, when it doubles, it's going to be $20,000, right? Times by 2, right? So basically what you see here is, I put it there, right? And then how many years is it going to take? Or you can, when the time is given, then you can do it vice versa. What kind of interest rate it will take to double your investment? I don't know why. This has got to be this. Okay. And rule of 72 tells you to figure out how many years it will take, you will need to divide the interest rate by, you will need to divide 72 by the interest rate. Okay. Of course, right now, in other words, the dividend is 72, and the divisor is the APR. But of course, it's not going to give you anything because APR is 0. But the idea is, of course, it's not doing that, right? It's not going to give you anything. And next question is then, why 72? Why? Out of all the numbers, why 72? And it's only an approximation by dividing by 72. Here, 72, you see it is 72%, not 72. 72% is 0.72. But then 72 is like 100 times 0.72, right? So is it 72 or 72%? Look, if the numbers are already expressed in percentage, if everything is in percentage already, right? So in other words, in this example, the numbers are, you don't have to put it in percentage. If, let's say, let me copy this. Copy that and paste here. No. Copy the whole thing. Now the mouse is acting up. And the I guess it's because of the battery issue. Okay, so if I bring it over here and suppose everything is already in. If the label already tells you the number down below is percentage, right? Then you can just simply, make these. You can express them just as, just number, right? Again, so because if you put 72 there, right, everyone will know, because it's percentage, that's 72%, right? Of course, whatever this comes out to be, it will be, also. Now, then why do you divide it by 70? Why do you divide 72 by the interest rate? Now let's take a look at actual calculation. So this is $10,000 principal, and future value will be in 5 years. We know the answer already in this case. 5 years, you want it to grow to $20,000 or twofold, right? Then what should be the interest rate? We know the formula for rate. Formula for rate is what? Future value divided by present value is 1 over n. So n is 5 because the compounding frequency is 1. So it's basically the same thing, but we will, because we have added additional columns for periodic rate and actual number of compounding. We'll first follow this because you have to always solve for periodic rate. So then n is in F12, but you cannot click it in because the formula is covering the cell, right? So I will manually type in G12, right? And then minus 1. And it's going to give you something. What happened? G12 over A12 raised to 1 over G12 minus 1. Why is it giving me this? G12 over A12. Oh no, this was G12. Something was. This has to be. Oh yeah, that's G12, correct? This is F12. I'm sorry, that was F12, right? There you go. We got the rate, and then since this is the period rate, and then annual rate. This is already annual rate because compounding frequency is 1. To convert it into annual rate, you will simply need to multiply by m, right? Okay. So let's try. So our rate is now given because it's pointing to this. Now how many years is it going to take? Because now APR is given. Now you divide by this. Oops, it's not. I'm sorry. That was supposed to be. This is not in percentage, right? This, but when you divide this by this, it's going to automatically find it as percentage, right? But actually, too many digits, so I'll decrease. Yeah, use only like 2 to 3 decimal places. So what does that mean? 4.8 4.84 years, which is an approximation, right? Approximately, it should be exactly 5 years, but approximately 4.842. Now, another way we can use rule of 72 is, so time is known, right? So you want to grow your principal twofold in about 4.82 years. What should be the APR? Then using that formula, right? The formula is what? I mean, rule of 72. I mean, the actual formula, actual formula. We can do better with the actual formula. We know how to do that. But using rule of 72, if you divide, 72 by APR, then that gave you time. Then if you divide 72 by time, then that should give you the APR, right? So divide that by, we'll give something like, right? Still, but if still this is, it will give you exactly that, because you divided that by 4.842, which was the result of dividing this by this. But what if this is 5? So roughly, you want to double your money in 5 years, then what should be the interest rate? It gives you a rough approximation only, right? Gives you a rough approximation. And if it was a problem about finding, we know how many years it will take if the interest rate is 14.87, right? First, we will find how many compounding frequencies, right? Of course, in this case, it's the same thing, because our compounding frequency is 1. In other words, it's annual compounding. So basically, the formula is natural log of future value over present value divided by natural log of 1 plus, in this case, R, the periodic rate. And you might, why periodic rate is the same thing as APR, because the compounding frequency is just annual. So in this case, it's the same thing. And we'll give you 5. And then converting that into years is simple. That's 5 compoundings, right? 5 period, and you divide it by M. That gives you 5 years. But it's all it makes difference when the compounding frequency is 4, like quarterly compounding, right? We all know already there will be 20 compoundings, right, over 5 years. And if you find the periodic rate, and you don't need to do it again, you simply paste it, right? Copy and paste. Then what does that mean? Periodically, so quarterly is going to be 3.53. And if you convert it into a annual rate, which is simply quarterly rate times 4, you see, and this conforms to what you have learned. The higher the compounding frequency, the APR doesn't have to be that much, right? Because higher compounding frequency takes less rate of return to achieve the same goal. Now, finding n, also you don't have to do this again. I'm gonna simply copy the formula for n and paste it here. And we get, of course, it's going to take 20 quarters, right? And then if you divide that by quarters, 4 quarters per year, then it's going to give you 5 years. So that's why that's how we should do it, actually, rather than using rule of 74. But why rule of 74? Why? It's because 72 is actually the result of, now let me use, okay. Now think about it. If the investment is doubled, what does that mean? The ratio between future value and present value is 2, isn't it right? Oh, why is it doing this? Yes. That means it has to be 2. In other words, right? Actually, it's natural log of 2, because this numerator has to be natural log of 2. Why? Because if FV equals 2 times the principal or present value, right? Right? Why is it giving me this? If that's the case, then of course the ratio between the two, then it's quite obvious. FV over PV is true. Makes sense? That's doubling your investment, right? So our question is then, we take the natural log of 2, and natural log of 2, if you do that, actually you will find it's something like 0.6931, and that, right? Now, so I found, this is, I found natural log of 2 here, right? And then natural log of 2 is 0.69 something. And since, the cell is formatted as percentage, it's giving you percentage. And so they approximated to 72. Why? Why out of all the numbers? I mean, was 69 or 70, 71, weren't they good enough? Look, 71 is obviously a prime number, right? And 70 only, rather than 70, 72 has, rather than 69 or 70, 72 has more divisor. There are more numbers this can be divided by, right? So they picked 72. So this is because this is the background, the origin of rule of 72. But this rule, but if there is a rule like that, rule of 72, what if you want to triple your money, quadruple your money? Yeah, all you need to do is, find, natural log of 3, natural log of 4, and find an approximated value. But then this doesn't work that well, right? Why? It becomes, inaccurate and unreliable. So then that's why you don't hear anything like rule of, 112 or rule of, 138, right? Why? Because, think about it. If it is triple, right? Suppose, doubling the money, right? What if it is tripling the money, right? No, I'm copying this. Copy and paste it here. Okay, if it is annual, it's going to be like that, annual compounding. Again, if you copy this, paste here, right? So you want to triple your money in 5 years. The interest rate that will take you there is 24.57%. And if you have, if the prevailing market rate is 24.57, it will take you 5 years to get there. But then think about it. So if you know the rate and find, years using, approximation of log of 3, natural log of 3, then it becomes only like this. And using, if you have timeline of 5 years and divide 112 by this, then APR becomes very, unreliable. I mean, inaccurate. Also, even quadrupling your money. So natural log of 4 approximation. It's almost, that number, not approximation. But then, APR is actually this would be the APR to triple your money, and then over 5 years. But and if you use that rule, if you use something like rule of 138, then time becomes very inaccurate. Also, if you want to grow it, quadruple it in 5 years, APR becomes this inaccurate. So that's why rule of 72 is only a particular case, and it's still an approximation. But they talk about it as if this is some kind of holy grail. That is a stupid thing, really. And accounting does a lot of, I don't know, accounting wants to make teaching accounting. I'm not an accounting professor, and it's a different, but all the accounting departments on a very low level, like 101, they want to water it down. Like, in other words, accounting doesn't teach you how to think. They just teach you, how to follow mindlessly some procedure. Of course, on a higher level, it requires a lot of thinking. But I don't know, it's just the promotional aspect of accounting. They want to make accounting more approachable to a large audience. So they make it something for dummies. And they like to make it something for dummies, right? So what's more important is not what rule of 72 is, but how and why it came about, how it works. In other words, why it works. It's pointless just to memorize to divide 72 by root. It's more important why the dividend is particularly 72, not anything else, and why divided by the rate. To know this, it's inevitable to introduce the concept of compounding, the properties of exponent, and the logarithm. Otherwise, you are just watching a demonstration of how to turn on and off the light switch without why and how it works. Without the theoretical background, in other words, mathematical background and logical reasoning behind it, you don't know how to fix when something goes wrong. And you can't tweak even a little, like how long it will take to triple or n-fold your money for a related example, right? If you don't understand how the electricity and its wiring works, you can end up trying to fix the light all the while leaving the cut knife switch on, right? Makes sense? So I've looked up, let me stop sharing this and let me share my, so a couple of, I've listed good links about, rule of 72. And the bad links, this is a very good example of a very bad link. Why? Very bad video. Why? Because this video is the typical example of just showing you what you put into the black box and what comes out without explaining what is happening inside the black box and why it works, right? So this type of video, I don't recommend this video, right? I'm only showing you this video as a bad example. Why? Because in the comments, some people, this is really ridiculous. Some high school senior or junior wrote, I don't know where it is. There was something here, I cannot find it. Maybe top comments, sort by top comments. Yeah, I don't care. Smart Joe, 10 months ago, posted, I'm a high school senior. I never heard about this rule before. Something is wrong with the educational system. Look, don't blame educational system. It's you. You're not that smart, Joe. Huh? You must have learned, if you're a high school senior, you must have learned some algebra at some level. Huh? You didn't pay attention in algebra class, probably, and you simply, or it's not your fault because you mindlessly, think this is a good demonstration, right? This video is not telling you anything about why it works, why 72 in particular. It's just, there's no causality, no explanation of what causes this, cause and effect. It's just, input and end result, input and result. This is not a good math, right? This is not anything conducive to making your brain smarter. This is rather making you like, conducive to getting you hooked onto a GPS like a robot, right? I've been telling you about, why people are, becoming more and more mindless as they, get more and more hooked onto the GPS. You don't think, you don't have a mental map. You just, react just, to the GPS prompt like an automaton, like a robot. Okay, so this is the problem of, so let me stop sharing that video and let me go back to, so this is address this issue because they are not demystifying. I'm in accounting class, very low level accounting classes, and some, this market trend that tells you that, kind of glamorizes, these self-learning courses like, something for dummies, glamorizing instead of demystifying something like rule of 72. Okay, so as I said, if you really want to deep more into it, I've posted a file with a list of good YouTube videos about rule of 72. Okay.
All right. So yeah, good. Here's the good video links to rule of 72. Right. The time is 7:16. So I think this is a good time to take a break. So let's take a 10-minute break and reconvene at 7:26. Okay? All righty. Let's take a 10-minute. All right, we're back. We're back. Um, so we're pretty much done with the topic 3, time value of money. There's just one more video I want you to watch because this came up in the past, from one of my past students, and well, this doesn't directly this is not directly related to you because she was asking, as she was doing some, chapter problems in Connect, she came up with this problem, and she had a hard time figuring out how to do it. And you're not doing any Connect problems, so it doesn't directly concern you. But I mean, eventually it will. Uh, you might encounter that type of problem at some point in the future. So, or if not in this class, in some other classes. So it is the case of future value of multiple annuities, right? We've seen only a single annuity case, right? Like future value of, let's say, future value of annuity, like, graduate school fund, right? Remember, annuities are usually also connected with the retirement, right? Uh, so uh, pretty much, pretty often you will find understanding how to deal with the multiple annuity problems. You will find it very useful later on for your uh, retirement planning, right? When you uh, when you get a job and when you work. Okay, so let's take a listen, right? Let's take a listen. Oh, let's see.
So what is your question today?
So I'm just having a hard time putting the problems in Excel and coming with the correct answer. Like even when I was doing Connect problems. So I don't know if it's like something along the my steps that I'm missing for.
Yeah, I replied. Did you get my reply? I replied to your question.
I saw your reply, but I feel like it would just make more sense to hear it. Hear what you say. Yeah, so, because I have a hard time learning, especially through math through this way.
But that's just the that's just average. I mean, what I'm saying is that's just common.
Right.
It's common for, and also it's pretty much a because it's a you're encountering for the first time a new way of thinking that you haven't. In other words,
Okay.
You haven't explored.
Let's.
Do you see this Excel file?
Yes.
Okay, great. So someone else also asked the same question about that, particular problem of,
like future values of annuities, right?
Yeah, right. And this is not this. It's a variant, because everyone gets a different, slightly, varied initial conditions, right?
Right.
So yours was like, I believe yours was like 350. Oops, why is it not changing? And another 350. See, the problem was like, you were able to make, $300, 350 payment into this annuity account for the first 30 years, or was it?
Okay, hold on. The verbiage, right? You might need the verbiage. So let me. I thought I downloaded the verbiage before, but where can I? was one of the chapters. So just bear with me. Oh yeah, I think this is. Oh, but there's the word part. I must have some words somewhere. Okay, I don't see. I typed in all the words in there. Where the verbiage? What's the verbiage? This chapter number 2. Okay, I guess I'm gonna have to go to my. Yeah, I'll have to.
It was.
Okay, I'll have to stop sharing for the moment. And just bear with me. And that one was. Oh, 7. Okay. 2520. 2520. Okay, so let's take a look at this. Okay, I need to share the screen again. All right, I wish you guys. So can you guys see this? Let me just increase the font. So take a look at the verbiage of the problem. Assume that you contribute $240 per month to a retirement plan for 15 years. So think about it. This is a future value of annuity. I mean, if you are monthly making a deposit of $240 into your retirement account, there will be for 15 years, there will be 15 times 12, right? And every monthly deposit will have accumulated interest, right? So this is, the first one will have earned interest, 15 times 12 times, or 15 times 12 minus 1, depending on, and normally you assume ordinary annuity, so 15 times 12 minus 1, right? And the second one will earn, interest 15 times 12 minus 2, and so on. Now, for the first 15 years, you deposit $240. Then you are able to increase the contribution to $440 per month for the next 25 years. Okay? Given a 9% interest rate, what is the value of your retirement after 40 years? In other words, what's going to be the future value of annuities after 40 years, right? So, but these 40 years will break down into two segments. The first 15 years where you contribute $240, and then remaining 25 years, you contribute $440. So most of the people think this is two separate annuities. That's where, in other words, just as I explained, the first annuity, most people think the first annuity ends at the end of the year 15, and the second annuity starts from year 16 and runs through year 40. So they think this way. And even if they think this way, if they just build the math, if they just build the structural formula correctly, then they will get it. But somehow, most people don't get it right. And then they think of these two as separate annuities. But if you think a little deeper, it's not two separate annuities, right? It is two separate annuities, but the first annuity doesn't end at the end of year 15. It keeps going. Now think about it. It keeps going until year 40, right? So, in other words, it doesn't, just because you increase the contribution to $440 from year 16, it doesn't mean these are two separate annuity plans. In other words, $240 monthly deposit keeps going for 40 years, and only from year 16, additional $200, annuity of additional $2 a month is made. So yeah, there are two annuities, but unlike, the first annuity ending at the end of year 15, and the second annuity is starting from beginning of year 16. No, it's not like that. It doesn't break down like that. It's more like first annuity continuing all the way from time 0 to time 40, year 40, right? Second annuity, and then there's second annuity, additional annuity starting in time at the beginning of year 16 and running until year 40, right? So the timeline for the first annuity is 40 years. timeline for the second annuity is 25 years, right? But most people think, oh, the first annuity timeline for the first annuity is 15 years, time 0 to time end of year 15. Second annuity starting from time year 16 and year 40, ending in year 40. And most people analyze it this way. I mean, so that's wrong analysis, right? But that's what this. Okay. So if you pay, if you're, if you need to pay attention to that and listen, and then you will understand what we're talking about.
The first
20 years.
Yeah.
Okay. And then from the 21st year, right, you were able to increase it to $700. Mm-hmm. And so what should be the future value of annuity at the end of year 50? So, yeah, this is something that people generally, because they never thought of it this way.
Okay. So here, think about it. In this example, right, the example varies every time, right? The input variables vary every individual, right? So in this particular example, for the first total timeline is 50 years. But for the first 20 years, this person was making $350 contribution to his retirement account, right? $350. Then from year 21, he was able to raise it to $700. But then think about it. His initial annuity of $350 doesn't end at the end of year 20. It keeps going to the end of year 50, right? And then when he raises his monthly contribution to $700, then that's just additional $350 starting from year 21. So the timeline for the first annuity is 50 years. Timeline for the second annuity is 30 years, right? This is how you need to. This is how you see it. This is how you need to see it. Okay. So everyone is clear about that, right? For the first 20 years, this guy was able to make $350 contribution to his annuity account, right? But from year 21, he was able to increase the contribution to $700, monthly contribution to $700. So, and the end of the timeline is 50 years. But then if you think about it, first annuity didn't end at year 20. It keeps going for 50 years. He's just adding additional $350 from year 21. So for the remaining 30 years, right? And if the interest rate is, in this example, was 7.2%, right? So, and because it is monthly, right? 5 years, 600 months, 30 years, 360 months. So future value of annuity of the first annuity was, future value of the first annuity was this. The additional annuity, right? Future value of additional annuity was this. And then, so the sum of those two is the answer to
this way. Right. And anyone who's encountering this problem for the first time would also think, your $350 deposits every month will terminate at the end of year 20, and you are getting a new, you're starting a new annuity starting from year 21 for the remaining 30 years, and you're making $700 deposits every year. And most people would think of it this way. They think the first annuity terminates at the end of year 20. But if you think a little further, you will realize that it's the same annuity. They in the problem, it never said the annuity ends. The first annuity ends at the end of year 20. You're just increasing the deposit amount. So it's the same annuity, right? Okay. So the first annuity of 350 keeps on going. You never cancel that account, right?
Right.
So it keeps on going for 50 years at the same interest rate, and then you are simply adding another annuity starting from year 21, running for 30 years.
Okay.
Make sense? So you have to split it into two annuities, like with one annuity with 350 going for 50 years. Okay, and it's a monthly. So of course, since that's a monthly, I have to find monthly periodic rate and the total number of months, which is simply like that. So that would come to this using the annuity formula. Okay, using the annuity formula, right? I taught you.
Okay.
Came to this, and the second one is starting from year 21 until year 30, end of year 30. That's 30 years, right? So same APR monthly deposit. So same periodic rate, and then that's going to be 360 months. And it comes to a future value of annuity. Will come to that. So then at the end of year 50, your future value of annuity will be the sum of these two.
Okay.
Right? Makes sense? So it is. That's why it's not uncommon. A lot of people encounter the same problem because they have never thought of it this way. But it's
okay. So I guess this one is the this one pretty much explains everything about that particular example. I don't think the rest in the video, I don't think in the rest of the video there is anything else. Just let me fast forward and see.
So yeah, because at time.
Okay.
Still gonna be able to
Okay. All right. So that's it. If you do you have any questions so far? Any questions? Any questions?
No.
All right, Malaysia. All right, thank you for Rustam. Yeah, thank you for responding. And I hope everybody is also listening. And so that takes care of everything about the time value of money. So we're going to move on to topic 4. Okay, we're going to move on to topic 4. I think we have about 25 minutes, and maybe not, because I guess in topic 4 is bond valuation. We're starting on so I don't know if this is 1 hour video. I mean, if it is 30-minute video, we can definitely cover it. Let's see if I can, how long this is. If it is 1 hour video, we'll have to stop at some point. Oh, it's 1 hour video. But I guess we can stop, at some point, midpoint probably. But the first part is pretty much overlap. I mean, we already discussed a lot about bond in topic 1, so it's a kind of refresher. The first part of this video is a kind of refresher. Let's take a listen.
And we know already pretty much about the bond basics because we started out this semester with return on investment. The topic was return on investment, but eventually we ended up discussing a lot about the bond. And the reason is because the bond return is the basis of the interest rates, and basically the benchmark interest rate is determined by the bond market operation by the Federal Reserve. So we discussed the basic concepts of bond. In other words, things like bonds can be issued by the federal government, specifically by the Treasury Department, and then by the corporations and by the municipal governments, right? So depending on who is the issuer, it's called by different names. Of course, if it is issued by the Treasury Department, it's called Treasury Securities, right? Treasury Securities, as a collective name, Treasury Securities. And the corporate bonds are called, issued by corporations, it's called corporate bonds. And also, if it is issued by the municipalities, it's called municipal bonds. And of course, also depending on the maturity, right? And I told you, bond is the name reserved for only the long-term debt instrument, right? The short-term debt instrument goes by different names depending on who is the issuer. I told you for Treasury, right? The short-term Treasury with maturity under 1 year is called the Treasury bill, right? T-bills, right? There are 1 month, 3 months, 6 months, a 1 year Treasury bill. And then Treasury securities with maturity between 1 and 10 years are called the Treasury notes. And then Treasury with maturity above 10 years and up to 30 years is called the Treasury bond. Okay. Also, for corporate bonds, right? Corporate bond is by default a main reserve for long-term corporate debt. So basically, the corporate bonds have maturity longer than 1 year, and it can be up to 30 years as well. But generally, somewhere between 1 and 10 years is most frequently used and traded. And the corporate bonds with maturity under 1 year is called commercial paper. Okay, commercial paper. And commercial paper, I also told you commercial paper is another name for promissory notes. And somewhere around the second topic, the financial statements, we discussed, the difference between, in the balance sheet, we discussed the difference between the commercial paper and the promissory note. And although they are, I just told you, they are the same, but, the way, the context in which they are used can be slightly different, right? We discussed that at the time. And then municipal bond is basically, bonds issued by the municipality. So here, this table, this is just a screenshot of the book. You may also find it in your, you will find it in your book. And depending on which edition it is, the number may be slightly different. But anyway, let's take a look at the first one. That's Treasury securities. And the coupon rate, first it shows the coupon rate, 2.75% per year, right? So that's the interest rate per year. And the interest rate is always based on the face value of the bond. And the face value of the bond is always $1,000, right? So at maturity, you will get $1,000. And until then, you will get 2.75% interest, which is also called coupon interest, annually, which is then $27.50 a year, right? Makes sense. That's 2.75% of 1,000. But of course, once again, the bonds pay interest semi-annually, right? What does that mean? The frequency, frequency of compounding per year, M, is 2. So actually, each coupon payment is made every 6 months, and it will be then half of this amount, right? If it is $27.50, then half of that. So that would be like $13.75 or something like that, right? And compared to that, corporate bond, in the first column, it's showing you the name of the issuer, CIT Group. Coupon rate comes in the second column, unlike the Treasury, right? Compared to Treasury, the coupon rate is quite high. Think about it, it's more than twice, right? Coupon rate is 7%, so that means annually $70, and that also means semi-annually $35, because the bonds pay coupons semi-annually, right? And the municipal bonds, CIT Group, you can look it up. It's something like in the insurance business or something like that. And the municipal bond was issued by New York City. It's called Water Finance Authority. So New York City government, right? And the coupon rate is 4.5%. So you might say, oh, that must be $45 a year. No, actually, it is not $45. Why? Because only the muni bond, right? Muni bond has different face value. The muni bonds have $5,000 face value, 5,000. Then 4.5% of 5,000, you can calculate that, right? I mean, if it is 5%, that would be 10% of 5,000 will be 500, right? So 5% will be 250, right? 4.5% will be slightly less than that. So anyway, that can be easily calculated. But basically, this is how the bond is quoted, right? Bond price and bond yield and bond data, bond information is released, or how it is released in the print media. Okay, in the print media, such as newspapers, right? But you can also look up bond quote information in online, but generally it's not easily found on Yahoo Finance or a very common bond, common stock quotation, stock information sites like Yahoo Finance. You would have to go to the special site set up by the called FINRA. FINRA, right? FINRA is the acronym for Financial Institution. Financial institution and national. I will have to look up the acronym. But what used to be FINRA is the sequel to what used to be called National Association of Stocks Securities, Security Dealers Association, NASDAQ, right? NASDAQ is a index, but NASDAQ is National Association of Securities Dealers Association, and that was quite. For a long time, they went by that name, but then they changed the name to, they reorganized as FINRA. So you have to, for bond information, you have to go to FINRA website. But in the traditional print media, this is the way it is released. Now, let's take a look at the next column. So for Treasury, right, the column and the second column, because first column was coupon rate, second column is the maturity, month and year. And it says February 2013. It's not February 13th, it's month and year, right? So it's not the date, February 2013. Of course, February 2013 is past for us. That was like 7 years ago. But when this example was taken, it was about 2010, around June of 2010. So at that point, 2013 was still the future. And the how do I know the example was taken? I'm not the author of this book. I'm the author of the custom edition, but the original book, I'm not the author of the original book. So I didn't take this example. They took this example, right? So how do I know? I mean, they never discussed, when they wrote the book. It's not like they discussed it with me. But I know I can, because I can backtrack it. How, you remember in the time value of money, we know how to solve for n, right? You learned how to solve the equation for n. So by solving for n, I could backtrack it to June of 2010. Okay, so take my word for it. Okay, I can show you later if you have more time how it works. But the point is, we can tell the this bond, but this is specifically called Treasury note. Why? The N here, right? The N stands for a note. So that means it was originally issued as a Treasury note, like 10-year Treasury note, right? And if February 13th, 2013 is the maturity, most likely this bond, this note was issued, Treasury note was issued in 2003, and March 2003, and then end of February 2013 will make it exactly 10 years, right? So that's what it means, that N, right? And And if you take a look at the maturity of this corporate bond, the maturity is May of 2016. And I told you it was around June 2010 when these examples were taken. So at that time, they still had like 6 years left, right, on this bond. Look at the maturity. Let's take a look at the maturity of this municipal bond. Maturity is like, June 15th of 2037. And usually, municipal bonds have very long-term maturity. So I would say this could have been 30 years, 30-year bond, meaning then it was initially issued in 2007, right? And with 30 years left maturity, right? And the time this example was taken was around June of 2010, so they still had, roughly, 27 years left. Now let's move on to the price quote, right? Let's go to the corporate bond first and muni bond first. Now, last price means the price at the last closing of the market, right? Last closing of the market. So most likely, yesterday, because think about it, when it is in the it's not online, this is on a print media like newspaper, so you cannot have the closing price of the day at the closing of the market on the newspaper of that day, right? I mean, even the evening paper would be out already by about 4 p.m., right? And then you cannot have that information printed already in the evening paper. So this would be printed in the the next day paper, right? But anyway, don't you find it a little bit curious how the price is that low? If that is the price, that means the price is $91.73, right? But now think about it. What is the face value of the bond? Did I say the face value of the bond is $1,000? Except the municipal bond, right? Except the muni bond, everything has, $1,000 face value, right? And think about it. This bond has, and since it was 2006, when, at the time this example was taken, it was about 2010, but 6 years left. Meaning, in 6 years, you're going to redeem $1,000, and until then, you get $70 interest every year for the next 10 years, right? And it's selling for $91. Does that make any sense? I mean, isn't it too cheap, right? Anybody would buy this bond. If this is true, I would buy this bond. It's not even $100. I buy it and collect $70 every year for 10 years. That alone is like $700, in simple aggregation, in simple sum. And then 10 years later, I get $1,000, which is more than 10 times, tenfold, right? So if this is the correct price, that is such a incredibly phenomenal return, right? That's like 1,000%, more than 1,000% return, right, for the 10-year holding period, and also including the coupon payment of $70 for 10 years, right, every year for 10 years. So something doesn't click, right? Something's not right for the price, right? Yeah, this is not the dollar price, right? This is not the dollar price. Clearly, if it is dollar price, this is crazy, right? No company would be, no company would receive just about $91 from you, and 10 years later give you, pay out $1,000, right? So this price is actually the percentage, right? Price expressed in percentage of the face value. So what does that mean? This is 91.735% of $1,000 face value, right? So that means this bond is at the last trading, right, at the closing of the market, at the end of last market, right? At the end of closing of the last market, the price was $917.35. Okay, that kind of makes sense, right? All right, and then look at the price. Then now you understand this is this is also the percentage, right? So that's 97.57% of what is the face value of the muni bond? $5,000, right? 5,000. So you can do a calculation. 5,000 times 97.57%. That would come clearly above like $4,500 at least, right? But then if you take a look at the bid treasury, right? Treasury note. It seems to have two prices, right? It doesn't have only one. One is called bid, the other one is called ask. Bid and ask If you ever bought or sold something on eBay, you would understand what bid and ask is. It's the price in auction. Price is in auction, right? Bid is the price that the buyer is willing to pay, right? And ask is the price that the seller is asking for, right? The seller wants to receive. So there are two prices, of course, in an auction, right? And of course, in a bond market, it's an auction because there are a stock market as well. There are buyers, there are sellers. Sellers always want a better price than the buyer's, the price that the buyer is willing to pay. Buyer wants to pay less than. The buyer wants to pay as little as possible, right? So there's a difference between bid and ask. That makes sense. But then, what is this? That I told you the prices are quoted as percentage of the face value. So that must be the percentage, right? But then there is something weird about the way it is written. Okay, if it is percentage, right? How do you read that? Is that 104.25%? Huh? If it is 104.25%, why is it decimal point? Why do they use colon, right? That colon. That's. But this is the weird system that the only the Treasury uses, right, for its Treasury securities. This is actually a 1/32 system, right? 30 seconds system, 30 seconds. That means this is 104% and 25/32%, right? 104 and 25 30 seconds, right? Oh, that is that's quite unusual, but you'll get used to it. You should get used to it. It's not that difficult. Well, basically here, numbers after colon represent 30 seconds of 1%, right? So what do? Why 30 seconds? Think of it this way. Let me switch to okay. Let me switch to the whiteboard. So in the old days, right? Okay, before the print media, newspapers were not, that common in the 16th and 17th, 18th century, right? Printing was, even rare. I mean, the although movable metal types was, invented in the like 1400 something. Actually, they say Gutenberg was the first, but actually, the Korean king in 15th century, and his court, the scholars of his court, first, even 100 years before Gutenberg, right, developed the movable metal type. But anyway, with the movable metal type, they could print books, but newspapers had to be printed every day, which was very rare, even until like 19th century, right? And then, but the stock market has been around since a long time ago. Even from the 16th century, they had 16th or 17th century, like 1600 something, right? Amsterdam in those days was the financial center of Europe. It was like New York City at the time, and they had stock market. But think about it. In those days, without daily newspapers that were being circulated that efficiently and effectively throughout the country, right? There was no way of delivering newspapers. Printing out newspapers daily is already a almost impossible task. They may print something once a month or once a week, but news. Stock market news, in other words, stock market news could not travel that efficiently. It could only travel by words of mouth or by horse carriage, by messenger, horse rider, and the news is no longer a news, because when the messenger on a horse arrives to the other corner of Europe from Amsterdam, that would be like weeks old, and even think about it, they will have to record it, and all those stocks being traded in the Amsterdam stock exchange, right? Without any print media, right? The horse messenger would have to record it in a very succinct way. And in those days, literacy was not that high. So the best way to, if you think about it, you may have seen let's say, if you drive a car or if you ever rented a car, you would see that if you look at the fuel gauge, right, the fuel gauge would look like this. There it is, full, right? This is empty. And this is half. And what's this? 3/4. Quarter, right? So in other words, if you're looking at the fuel gauge, you get the idea. You can easily grasp the reasoning behind the 30-second system. Now, when you split it once again, what does it become? 1/8, right? 2/8, right? Half, 7/8, right? So in other words, if you split it multiple times, for example, 2 to the negative third, that's 1/8, right? If you split more time, it's going to be 2 to the negative fourth, which is 1/2 to the fourth. And that's, of course, 1/16. And if you split it one more time, what's it going to be? 2 to the negative fifth. That becomes a 30-second system, right? 30-second. 2 to the 1/2 raised to the fifth power, and then that's 1/30 seconds, right? Now think about it. This was in those days, this was easier to record. I mean, when they didn't have, probably this was visually more effective. But anyway, this is I'm not saying Federal Reserve, Treasury did it this way because it was for the same reason as this, but the logic behind it is pretty much the same thing. So let me switch back to
okay. It's not. we have to cut it short here because it's already 8:14. But this explanation is, you've heard it. You've heard it so far, and by now it is clear. It would sort of emerge as a clear picture to you why they use 30-second system, right? Of course, if you continue to listen to the rest of the video, it will be more, it will be better, and you have a complete explanation. But we'll have to pick it up from here tomorrow. Okay. Alrighty. So we'll call it a day here. I'll call it a night rather, and I will see you guys tomorrow. Have a great evening, everyone, and see you tomorrow.
Thank you.
All right. You're welcome. You're welcome. Take care. Take care, Zaniad.
Thank you. Have a good night, Professor.
Okay, you too, Cornell. Take care, everyone. All righty, so I'll stop recording.